Now dear student, we are going to discuss this question number 7.16, and in this question it is given to you, obtain the answer to A and B in exercise 7.15 if the circuit is connected to a 110 volt and 12 kilohertz supply. Clear? So I already draw here this diagram that you have already seen, and input supply voltage is given 110 volt and this is 12 kilohertz. Clear? It is also given here, explain the statement that a capacitor in a conductor, capacitor is a conductor at a very high frequency. Clear? So now we can see, actually we know if we calculate here value of I naught, clear, I naught, this is given by V naught divided by, now you know here we will write here value of Z, clear. So value of Z, this is given by under root of, I can say R square plus XC whole square, clear. Value of V naught you know very well, that is 110 multiply under root 2 divided by under root of R square. R means I can say 40 square plus what about XC, clear. So if I calculate here value XC, this is given by 1 upon omega C, clear, and we can say this is equal to 1 upon 2 pi, clear. XC equal to what? This is given by 1 upon omega C, and 1 upon omega C, this is equal to what? 1 upon 2 pi, and F is given to you, this is 12 into 10 to the power 3 divided by, clear, 2 pi into 12 into 10 to the power 3, and what about C? I can say 100 into 10 to the power minus 6, clear. So from here I can say this is equal to 1 upon, I can say 24 pi, clear, 24 pi into 10 to the power 5 multiply 10 to the power minus 6, clear, yes or no? So from here we can see this is given by 1 upon 24 pi, clear, and multiply 10 to the power minus 1, clear. So now if you write here we can say this is 10 divided by 24 pi whole square, clear. So from here we can say 24 multiply 3.14, so near about 72 we are getting, clear, and we can say this is what, 0.1 something, clear. So from here we are getting this value 110 under root 2 divided by under root of, I can say 40 square plus this is 0. I can say this is 0.133, let's suppose, clear, and that is whole square. Now you can say here value of this 0.133, this is very less compared to this 40 square, clear. It means we are neglecting that value, clear. So from here you can say we are getting maximum value of current 110 under root 2 divided by 40, clear. So value of I naught we are getting 110 under root 2 divided by 40, clear. We can say this one and this one cancel out, so 11 by 4 multiply under root 2, so 11 by 4 1.414, clear. So from here we can write like this, this is 11 by 4 into 1.414, so let's suppose this is 1.4 only, so we have 4 and I can say here we have 4, so 15.4 divided by 4. So now if you calculate it you will find here this is 3 point, we have here 3, clear, so near about 8, so 3.8 ampere. So maximum current that we are getting in this circuit, this is 3.8 ampere, clear, yes sir. Now you can say let's suppose if we neglect here this capacitor, because you are neglecting here resistance that is offered by capacitor, clear. So it means we can say at a very high frequency, clear, what is given in this question, frequency is very high, clear. So at a frequency of very high frequency, if we are talking about high frequency, at that time you can say this capacitor behaves just like a straight wire, clear, or it is just behaving like a conductor, it is offering a very little resistance or very less resistance, clear. It means I can say at high frequency, clear, what is happening at high frequency current at high frequency, what is happening, we can see this capacitor at high frequency, capacitor behaving as a conductor, having a very low resistance, Clear? Yes. Clear? So at high frequency, capacitor behaving as a conductor having a very low resistance. Clear? So this is all about current. Clear? Yes. Actually you can also find here that is phase difference. Clear? If we talk about phase difference, you can see 10 phi. 10 phi, this is given by, I can say that is Xc by R. Clear? Value of Xc, this is equal to 1 upon omega c multiply R. Clear? Omega, I can say value of omega, you can say 2 pi f. F we have 12 kilohertz. Clear? Capacitance, capacitance value we have 100 microfarad, 100 into 10 to the power minus 6. Clear? And what about value of R? Clear? Resistance, that is 40 ohm. Clear? So from here you can say this is 10 to the power 3, this is 10 to the power 5, this is 10 to the power 6, this one all are cancelled out. Clear? From here we can say this is equal to 24 pi multiply, is there something? Yes, that is 4. Clear? So near about you can say here this is 24 multiply 4, 96. So 1 upon 96 multiply 3.14. Now you can say here you are getting a very less resistance. Clear? And you can say here near about you are getting this value 0, near about. Clear? Or you are getting a very less value. Clear? So I am saying not 0, directly we can say this value we are getting 0.00, let's suppose 1 something. Clear? It means I can say value of phi that we are getting, this is equal to 10 inverse 0.001 something. Clear? It means I am saying here value of phi, this is near about 0. Clear? It means what you are understanding by this definition or by this angle. Actually we are understanding here the resultant is making a very less angle with resistance. Clear? Or we can say value of Xc is very low. Clear? So like this you can prove at high frequency capacitor behaves just like a conductor that is having very less resistance or negligible resistance. Clear? So this is all about this question. Dear student, we have one more question in this particular question. It is given here when you know Xc, that is given by 1 upon omega c, this is given by 1 upon 2 pi fc. Clear? Now whenever we have a DC current, whenever we are talking about DC current, so for DC current I can say frequency this is equal to 0. Clear? So for DC we have value of f that is 0. So from here we can say this is given by 1 upon 0 and near about infinity. Clear? So I can say we are getting here this value near about infinite. Clear? So I can say if we are talking about capacitor, if we connect capacitor in a circuit where a steady current is flowing, at that time this capacitor actually behaves just like an open circuit of a open circuit. Clear? Or you can say it will not allow DC current to pass through it. Clear? Clear? So this is all about this question.